Hello everyone, welcome back to the channel. Now let's find the value for this one. Here we have x plus 1 over x is given 3. Now let's find the value for this. Now to find the value for this, let's assume a n is equals to x power n plus 1 over x power n. Now, to find the value for this one, which is x power 5 over 1x power 5, we use the recurrence relation. Now, in this recurrence relation, for any value where x plus 1 over x is equals to k, then in that case, to find an, we have k a n minus 1 and then minus a n minus 2. So this is the relation that is defined under the recurrence relation. So here the value of k is given, which is 3. So whatever the constant is here, that is equals to this constant value. So here in this relation, the value for k is 3. Here we assume an is equals to x power n plus 1 over x power n. In this relation, if we say a is 0, in that case, the value of x power 0 plus 1x power 0. If the exponent is 0, for any base, the value is equals to 1. Here same, the exponent is 0, so the value is 1 here as well. That simply means we can write this 1 plus 1 over 1. And that simply means 1 plus 1, which is equals to 2. That is the value for a0, which is 2. Now, similarly, instead of n, if we write 1, so here the value of n is replaced by 1. So n1 here. That means we can write the relation x power 1 and 1 over x power 1. It simply means x plus 1 over x. And the given value for this is 3. So x plus 1 over x is 3. That is the value for a1, which is 3. Now, since we have the value for a0, which is 2, and the value for a1, which is 3. Now, we can find the remaining value for like a2, and then we can find a3, we can find a4, and we can find a5. Once you have the value for a5, then we can find the value for x power 5, x power 5. Now, to find the value for a2, we use this relation. Here we have the value for a0 and a1. So once we have these two values, now we can find a2. So this n is replaced by 2. Same here, 2, and this one also 2. Now we can write this relation k2 equals to, here k means the value is 3, and then a2 minus 1 minus k2 minus 2. Once again, this is the value for k. So the value of k is from this one recurrence relation, but the k is equals to whatever value is given here. In this case, 3 is given. So this k is replaced by 3. And for 2, we replace this n by 2, this n by 2, and descend by g. That simply means, so you can rewrite here, it's 3, this a1 minus a0. The value for a0 from here is given, which is 2, and a1 is 3. So simply we replace those values. Now this is 3 times 3 minus 2, which is 9 minus 2 is equals to 7. Now we repeat same here for a3. Again, the value of this n is replaced by 3. So this is 3 and this is 3. Now we can write 3 a 3 minus 1 and then a 3 minus 2. Simply rewrite it is 3 a2 minus a1. And the value of a2 is just calculated, which is 7, and a1 is 3. So we have the value of a2 from here, which is 7, value of a1 from here, which is 3. That means the value is now 21 minus 3, which is 18. So same for a4, which is now 3 a4 minus 1 minus a4 minus 2. That is 3 a3 and this is a2. Now we have the value of a3, which is 18, and a2 is 7. That simply means it is 54 minus 7, which is now 47. You can find for a5 as well, which is again now 3 a 5 minus 1 a 5 minus 2. Now this is 3 times a4 and this is a3. Now 3 a4 is just calculated, which is 47 minus a3 is we have 18. That also means now 47 times 3, which is 141 minus 18. That means the value of a5 is 126. So we assume here the value of an is equals to x power n plus 1 over x power n. So since we have the value for a5, which is 123, so this is equals to x power 5 plus 1 x power 5. Because this n is 5, means this and these two n's are also 5. So you can write here where kn is equals to x power n plus 1 over x power n. That means if this is 5, then it's 5 plus 1 x 5, which is equals to 123. So this is the answer for that. So from these calculations, first you find a0 and a1. Once you have these two values, so we use this relation to find a2, then we use a1 and a0 to find a3, then a2, a1, for a4, a3, and a2. So we use here for a5, a4, and a3. That means each term depends on previous two terms. So this is when we use the recurrence relation. And this is how we can find the value for x5 plus 1 over x5 using the recurrence relation. So if you have any confusion, please go through the process once again. And you can write in the comment section below. I'll see you in next video. Thanks for watching. Till then, take care. Goodbye.